It's cheaper than ever to get to space. It's cheaper to launch. You got SpaceX putting up 14,000 communication satellites, and they're launching no matter what. And there's people doing ride shares, but those ground stations are the critical piece, because those ground stations spread throughout across the planet are the opportunity for when the satellite comes within range that it can transmit the data that's collecting back down to the Earth to be processed and leveraged.
Hello and welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Daniel Bradley. He is the co-founder and CTO of a company called Astraea. Astraea is heavily involved in the Earth observation space. They're building a lot of interesting tech around that, and Daniel has agreed to come on the show today and give us his insights into this industry. Just before we dive into the episode today, I want to remind you that this podcast is sponsored by OpenCageData. So OpenCageData is a geocoder, and Ed, one of the co-founders of the company, he's actually been on this podcast a couple of times before, talking about his work with geocoding and talking about his work in the geospatial community with a group called GeoMob. I have had the privilege of working on a few projects with Ed and with geocoding, and it's been an absolute pleasure. I really admire what he's building over there, and I would encourage you, if you have any geocoding needs, to check out OpenCageData. Okay, on with the interview. Hey Daniel, welcome to the podcast. So today we're going to be talking about Earth observation. We're going to be talking about the past, present, and future of Earth observation, and I'm really looking forward to the conversation. Now, you are the founder and CTO of a company called Astraea. You're dealing with Earth observation data and you're building a platform around that, and we're definitely going to dive into that later on. But before we get into that, it would be really useful if you could give the audience a brief introduction of how you got involved in Earth observation remote sensing.
Sure, absolutely. Excited to be here and really passionate about this discussion and this topic. I got infected really with the power of satellites and extracting information from satellites as a young soldier in the late 90s. It was kind of heady times where, being able to pick up a phone and requisition a satellite in support of, operational intelligence support centers where we're supporting warfighters and leveraging that information and multiple data feeds from drone, aerial, satellite, human intelligence, and what they call all source intelligence to extract information. And that was kind of my first aha moment, wow, this is incredible. The information and data that is being collected at that time in the late 90s, it was pretty much isolated to the government, to the Department of Defense and intelligence type operations specifically for Earth observing satellite imagery. Kind of in the mid 2000s, I transitioned out of the government into private sector and was focused on helping individuals, organizations make sense of operational data. My math and stats background, led me to the AI ML. It was just the burgeoning field that it is today. I was fortunate enough to work across a number of different industries: insurance, oil and gas, telecom, software, all around making sense of data, leveraging AI and ML techniques to do so.
You said a whole bunch there, and I just want to back up a second because first of all, I want to point out to the listeners that you are the very first infected geographer that we've had on the show. We've had lots of accidental geographers, but you're the very first one who talks about themselves being infected by this, and I think that was worth pointing out. Secondly, you talked about a maths and stats background. So does that mean that you're not coming at this as a geographer, someone with an interest in geospatial? You came in it from the side using your understanding of maths and statistical analysis?
Absolutely, yeah. I'm very much a non-traditional. I didn't have a background in geospatial, geography. I come at it from a math and stats, computer programming type of approach.
I think it would also be really useful for the listeners to understand what those early days looked like in Earth observation. So you talked about being in the military, and you talked about looking at Earth observation data and trying to sort of get some information out of that. What did that process look like back then? Are we talking heads up digitizing where we're drawing circles around interesting objects and georeferencing those, or what did that process look like?
Yeah, it involved all of that. It's a very, very manual process. Teams of people, it's throwing bodies at it. We didn't have a lot of the advanced techniques and the deep learning and a lot of those computer vision techniques that we're seeing applied today to the space. So it was drawing, digitizing, cross-referencing that with other platforms and intelligence assets, and so very, very manual process. I remember many nights going home with headaches about every night because it's just a deluge of information that you're trying to make sense of.
And I can imagine, so identifying those features would be one thing, but tracking them across time would be a whole nother thing, and then making sense of that with your other team members. Like, did you get that also, or is that the same object there? I can imagine that side of things. Those kind of things that we perhaps take a little bit more for granted today would have been incredibly difficult.
Yeah, there wasn't, not a ton of great collaboration tools. We often think about satellite imagery, aerial imagery is really where it started, and photogrammetry. But now it's everything censored. And those sensors are, the only thing we were doing with the imagery is really still a measurement about the Earth. We're observing the Earth and measuring the Earth. Now we can do it on a number of different platforms, and it's just increasing.
Yeah, so let's stay with that theme for a little bit here, because one of the things I really wanted to talk about was like the future of Earth observation. So we got a little snapshot of what it looked like in the past, that kind of heads up digitizing and all the sort of problems that involve with that. And then the solution back then anyway was just get more people to do it, and then we can do it faster because we have more people doing it. So the world looks quite different today. And in a recent post on Medium, you talked about a concept called Space 2. Could you give us a little bit of an overview of what that means for you? You talked about a confluence of a couple of different factors, which I think would be really interesting to talk about.
I certainly didn't coin, and Astraea didn't coin the concept of Space 2.0, but we certainly have been in the middle of it. The future, and I hate to say, you said something just a second ago. It was really interesting. It's like, it's certainly not the way it used to be. But unfortunately, it still is a lot of that way. You take the National Geospatial Intelligence Agency, NGA, just 3 years ago, they were doing a modernization effort and kicked off a huge modernization effort to try to get away from the manual processing of this data. And so some of the leading organizations and extracting information from this are still struggling with modernizing beyond throwing humans at it. So we're just at the very beginning of scratching the surface of what is this new wave. And that's what Space 2.0 is, to me, all about. It's how do we better leverage cloud architectures, AI ML techniques, multimodal data fusion techniques to unlock better insights about the planet and make better decisions.
So I'm not sure if you're familiar with the Gartner Hype Cycle, but this sounds like a thing that we could perhaps, a model we could apply to this situation to help better understand it. So the hype cycle says that there's a trigger in technology, something new is available. And I think that's probably what we're talking about here when we talk about machine learning and cloud architecture, and obviously the increased availability of satellites. So something new is available, that's the trigger in the market. And if you follow the curve here, it says straight away the peak of inflated expectations. And then we drop down to something called the trough of disillusionment, up the slope of enlightenment and the plateau of productivity. Could you give us your insights there? Where do you think we are on this hype cycle?
Well, it's interesting. So I come at it from a very different perspective. I come at it from the AI ML space. The whole satellite industry, it was only about 25 years ago in 1984 where the U.S. Commercial Space Act was put into place that allowed organizations to launch satellites into space for the purpose of remote sensing of the planet and make it commercially available. So that's only 25 years ago. But we forget how short a time has actually passed. And it was in the 70s where we had the AI winter, where, like, to your point, it was a new shiny technique. We had more computer processings. We had things called neural networks and other things of that nature. And everybody got excited that we can mimic the brain and get to artificial intelligence. And then there was a big backlash because we were at that peak of inflated expectations. I think there are some parallels to Space 2.0 and leveraging this new data source. There's been a flood of venture capital and other money come into the space, a lot of startups like ourselves working in it. And a lot of the businesses and organizations are grappling with the business cases, the use cases. Where's the justification to leverage this data set? Does it make a lot of sense to count cars in Walmart parking lots? Or can I get better data that's actually cash register receipts or other ways to get that data that is more effective? And so we are at risk, I think, right now of falling into that trough of disillusionment.
That was really interesting to have you put that perspective on it in terms of time. So when this thing started, because 25 years ago, 30 years ago, that's a long time ago. This is, we're talking about in the incredibly early days of the internet. We're long before smartphones. So that seems like a long time in the tech world. So I guess it's understandable that people had some different kinds of expectations back then. And it's understandable that people look back and go, wow, maybe we should have come further. Perhaps what's happening here? So if we stay with this idea of the hype cycle just for a second, so you think we're perhaps falling down to the trough of disillusionment. And is that because that perhaps people you were talking before about people struggling to find applications for this? Is there anyone who has found an application for this? Can we point at any one or two particular industries and say, okay, they have found a use case, it's working over there?
The most clear use case has and continues to be Department of Defense and intelligence use cases. They have been leveraging this and are the leaders in cutting edge technologies for Earth observation. But it's really about now, how do you commercialize? Because it's only been really commercially available for roughly 25 years. Insurance and finance and agriculture and others have went a long time without leveraging this data and have been just fine. Now the question is where are those use cases? It's really interesting to me that I think the timing, and you kind of talk about time, I think it is a matter of time. The timing and the time to adoption is being accelerated by a lot of the events that we see going on around it with climate change and a changing planet. And this is a unique opportunity that the technology is available, is promoting, the ability to launch satellites, the ability to measure the planet is available to unlock some of those insights and to find those real use cases that will propel the adoption of this technology and hopefully get us through, maybe we won't spend as much time in the trough of disillusionment for Earth observation as perhaps other technologies have in the past.
Well, I hope not. I'm looking forward to seeing what applications this has and where people find some really, really cool use cases for. But interesting enough, we both did this. We both thought about the military aspect of this. We both thought about how governments are using this. But if you think about the name, what we've been calling this technology for a long time is Earth observation, observing the Earth. Mm-hmm. I think over the last few years, it's become more and more apparent that we're facing some pretty big challenges in terms of what's happening with our Earth. But yet it doesn't seem that that's the go-to answer for this technology, or the go-to use case, I should say, for this technology. Do you think that'll change, or is it always going to be sort of industry profit driven?
I think it'll change. At least I hope it'll change. That's part of the reason why we created this company, was to help hopefully do our part to propel change, because I think it is, at Astraea we kind of focus on that. We believe it's the right of everybody to understand their planet and how it's being used, and trying to create better accessibility to this data and to leverage it for a wide set of use cases. But it is all focused on sustainability, and I'm encouraged by the fact of one of the big thought leaders, Larry Fink, BlackRock CEO, hedge funds, one of the largest hedge funds in the world, recently came out in his annual letter and said that climate crisis will reshape finance. And we've been fortunate enough to see that there's a big movement in finance and financial markets to focus on sustainable finance. And what does that mean? And how and to add to evaluating companies on their practices and having sustainable operations. And the way to do that, one way to do that is to use Earth observation data to evaluate how their operations are going, and to evaluate things like stranded assets as we transition from a coal-based energy environment to a renewable energy-based environment.
So right at the start there, you talked about your company, Astraea, and you said, this is why we started the company. It seems to me that there's lots of companies out there that are are interested in this field, and they're trying to help these companies learn, or trying to help other people and organizations learn what they can do with this data and trying to be involved. They want a piece of the pie, essentially. How is what Astraea is doing different from these other players we see out there? What are you guys doing that makes you special?
I try to focus on a yes and mentality. I don't really look at it as competition as much. I think there are worthy competitions out there, but I think the problems, there's no end to the problems that we face as a society, and that we're facing on a planetary scale. And so we focused on leveraging, creating an ecosystem, and really trying to help overcome the fragmentation that we're seeing in this space. All the different data providers, data sources, it's big data, the amount of the fragmentation of the skill set that you need to access the data, to turn the data into information, to make that available to other folks that aren't going to write in Python or use an AI ML technique, that may want it on a map, or they may want it in a chart or a graph. And so when we think about it, is there's a couple of different dimensions to this, right? There's the skills dimension necessary. And so at Astraea, we focus on providing a number of different platform products that are increased accessibility for a number of different user types. If you just want to look at an image and see the change from today and 5 years ago over your city, you can do that. If you want to get more advanced, we provide you the platform and the scalable compute assets to do that. We're really focused on the business to business enablement. And I think that's where we're a little bit different. We're not trying to be all end all solution provider. We want to enable specialists in the fields, all the different agronomists and utilities and energy players that could use this data. How can we help them incorporate this into their offerings and to the end customer that they serve?
So let's stay with that for a little while. So if a business comes to you, and I guess it really depends on what industry they're involved in, what sort of business they have, what's your approach to them? Is Earth observation data always the right answer?
No. Yeah, no, I'm sorry. I think that's one of the things. Is like, it kind of goes, as technologists, we're often guilty of creating a tool, creating a hammer and looking for a nail,
Yeah.
like, right. And that's fair. And that's kind of our predisposition as technologists. And Earth observation is cool, and it's a lot of big data, and AI ML is cool, but it's a technology, and we need to be business driven. What are the problems, and what's the best way to solve that problem? And that's why when I think about, we're on a geography podcast, and that's fair. When we think about Earth observation, we typically equate that to satellite, but there are a number of different platforms and increasingly other data streams that are observing the Earth, including from your cell phone. There's there's a number of interesting technologies going on, crowdsourcing platforms where people are taking pictures that then can be stitched together and fused with satellite data and LiDAR data and create awesome 3D maps. And so we can fall in love with the technology, but we gotta fall in love with the business problems and what's the best way to solve that.
Yeah, I completely agree with what you said there, but I could see how it's confusing for people. It's exciting and confusing, right? On the one hand, we have this what seems like an incredible opportunity. All this new stuff is coming onto the market, and we know from well, history has taught us that the first person to get these new tools, grab them and find a use case for them and really take advantage of them, they can have some huge benefits. If we think about what happened in the early days of the internet, for example, the first people to make websites, the first people that realized that Google, that I could buy AdWords on Google, they had a massive advantage. So I could understand people wanting to grab these tools and make use of them as soon as possible. So it's really interesting to hear you say it's not always the right answer. When is it the right answer? What industry is it just made for? Or can you see immediate benefits of utilizing it?
I think the shining example that we're seeing, and this is why to me it's exciting, is you think about global development and sustainable development goals from the UN, and so understanding across borders economic indicators and other things, that is a purpose-built use case for this data, just because of the large geographical region that that data can be collected on from the Earth observation satellite platforms. If you're more localized business, you're like, well, that's great. That's, those are big governmental still kind of use cases, and you got the DoD and those use cases. Got it. That's interesting. But what about me? How does this impact me? And I think that we're seeing more and more use cases on infrastructure monitoring, right-of-way monitoring, in the property insurance space of understanding what's on homes and what's, our solar panels going on homes. I think that's there's some very interesting use cases that are much more localized that this data is increasingly being used for.
I think you're right. I think monitoring in general is a really big category. Just being able to watch things change, see how they're developing, and try and identify trends based on that. I think that's going to be really interesting in the future. But I can see a massive amount of barriers too. Like, again, it's all very exciting at the moment. But what about identifying meaningful change? That must be something that's difficult. To say a pixel's moved from red to green over the last 3 or 4 days. I mean, we can all imagine that and do that, but meaningful change is something different. What does the timeline for this look like? Is this something that we're going to realize in the next 5 years, 10 years, 15 years, or are we going to be waiting another 30 years?
It's a great question. If I could answer that, we'd both be rich. It's a super challenging space. Without getting too techie on the AI ML case, you hit a lot. There's a lot of components in that to unlock you mentioned. It's like you're absolutely right. Change and understanding the change is of utmost interest to a lot of folks. There's a lot of barriers to that in leveraging this data. Cars and parking lots, it's not going to be the same algorithm as coral reef health, monitoring that across the entire Caribbean. That change is detecting that change, and the required processing of the data and the algorithm is very different from one another. There's components that are shared, but it's different. And so the barrier, and I know people talk about stuff, but the barrier specifically in teaching a machine is you still have to have that labeled training data. You have to have not just examples of the change that you care about, but of other changes so that the computer can start to discern. When you think about kids, it's not that much different. You're teaching your child. I have a couple of young kids, and at first they start to say everything's a cat. Everything that has a tail and ears and a little bit fuzzy is a cat. And then over time, you start saying, no, that's a dog and that's a cat, and they start to understand the difference between what those two animals, those two species, and that's equivalent. When we're talking about, and I'm being an AIML, this is what makes this really challenging about applying to this to Earth observation data, is that there is just so many variations, and the planet's a big place, and so many different types of change and underlying land cover types, and that we're going to be busy for quite a while to get to a fully, automated capability to detect all types of change of all variations for all use cases. And it's going to take a lot of dedication of creating those labeled training data sets. And there's some great work going on from nonprofit groups like Radiant Earth that has an ML hub that is focused on, it's open source and GitHub. It's so focused on creating those some quintessential training data sets and benchmark data sets that we can understand how these algorithms are doing across a number of different use cases. And then there's a number of interesting open source projects to help with the labeling of that data, and increasingly companies, social good companies and others that are focused on providing those labelers. It kind of started with Amazon Turk, which got really, in the AIML space, Amazon Turk was the early indication of that. But doing this on geospatial and Earth observation data, there's uniqueness to it. And so we're increasingly seeing more and more specializing companies and tool sets to help us create that labeled training data sets so that we can unlock the potential of applying machine learning techniques to Earth observation.
I've been recently talking to other thought leaders in the space, and it seems to me that the general consensus out there is that people, skilled professionals in this field, they're going to move from doing these kind of analysis on images themselves and sort of move more towards helping create training sets for these algorithms. Would you agree with that?
It has to happen. There is a lot of interesting work to try to create synthetic data sets and use other techniques, which are really interesting. These kind of physics based synthetic data sets, and there's a lot of research and academic research going into that, and that's an effort to try to shortcut the manual labor process of putting manual process of putting people against creating these label training data sets. We got a ways to go there before we can only rely on those kind of synthetic data develop processes.
So briefly, before in the conversation, we mentioned that Earth observation is not just data collected from satellite platforms. It can be from a lot of different kind of platforms. So obviously, that is aerial platforms, that's drones, that could be cell phones, and increasingly, perhaps also cars. I would imagine with cars being equipped with cameras and moving around the world. Is there any one of those platforms, or perhaps one I haven't mentioned, which you think it has a whole bunch of really exciting capabilities or promise at the moment?
Interesting question. I don't know. As a technologist, I see the value of all of them. I think satellites continue, as a class of data, continue to be exciting. There's a number of impending launches of new sensor types, hyperspectral, more synthetic aperture radar, lidar, other RF, other sensor types that are going to help us understand methane emissions and a lot of these other big drivers of climate change. So that's super exciting. One of my good friends is recently, entrepreneur as well, started a company called Pixel 8, and they focus on taking cell phone data where you take pictures and conflating it with satellite derived imagery to create these high fidelity 3D maps. And I think that's a really interesting use case too. Globally, everybody's walking around with a cell phone in their pocket, and those are very, very powerful machines that have a concept of position, and they have the ability to absorb the earth. And these crowdsourced platforms that are pulling that in, it's really though, how do we handle that data, and then how do we fuse it with other data and to orthorectifier data and to all the processing steps we have to do to make sense of it. And I think those are pretty exciting. We are seeing a lot of drones, another area. More and more demand for drone data is coming down. But once again, this is where, being a young industry, in Earth observation, we're still grappling with having standards and standards-based approaches so that it makes it easier to discover these data, make it easier for these data to work with each other. And I think continuing to push on that is going to be important so that we can make use of all these exciting new data sources coming online.
And I think that observation there, that really speaks to that idea of market fragmentation that we're seeing at the moment. There's so many players out there at the moment. I think in some ways I feel like a lot of them are going to have to die off. We're going to have to establish some clear winners, and those winners are going to step up with their standards and say, okay, this is what Earth observation data looks like from now on, kind of thing. And even though that sounds really bad for the industry, I think in some ways it's going to simplify things a lot.
Yeah, absolutely. I think we're already seeing it. I mean, there's definitely some consolidation going on. I think what we haven't seen yet, though, is we see consolidation within one of those kind of data streams. So in the Earth observation space and the satellite space, we're seeing some consolidation. I mean, one of the big newsworthy events was when Digital Globe and MDA merged and created Maxar. But that was still within that kind of satellite space. What's interesting is the players like Microsoft, some of the traditional AWS, AWS mentioning or not mentioning, but announcing last year that they were going to outfit most of their data centers with satellite ground stations. And so I think you're right. I think we're going to see it, but it's going to be interesting to see how it plays out from this, the state of Earth observation, where we have technology companies that are working across all these platforms.
Could you just walk the listeners through what you mean by these ground stations? Are they satellite launch pads? Are they places where data can be downloaded from satellites? What does that mean?
It's cheaper than ever to get to space. It's cheaper to launch. You got SpaceX putting up 14,000 communication satellites, and they're launching no matter what. And there's people doing ride shares, but those ground stations are the critical piece, because those ground stations spread throughout across the planet are the opportunity for when the satellite comes within range that it can transmit the data that's collecting back down to the Earth to be processed and leveraged. And so having these ground stations co-located with data storage and compute assets that we more and more do in a cloud native environment reduces that time to operationalizing it, to getting it and making decisions on it as an organization.
That's really interesting. That's a piece of the satellite infrastructure that we don't often, or at least I don't often think about. I tend to focus on the rockets that are launching the satellites, and not think about how much it takes to get that data back down to Earth. And then, of course, like, it makes perfect sense to be downloading that data at the same place where the data is potentially going to be processed, instead of having to move those huge volumes of data over to another storage center to process it over there. That was really interesting. Thanks for that insight.
No problem. I think you talk about the next future, and this is as it gets launched, is more and more people, as we find these high value algorithms like detecting methane, those algorithms are actually being put on the sensors itself. And so instead of transmitting down the raw data that then has to be processed, we're starting to see some applications where we're actually applying the algorithm on board on the satellite itself and transmitting down the answer. And so that's really where the space is going. That, how do we speed up the time from the collection of the measurement, the pixel have you, to the insight and to drive decisions and to make decisions.
That's really interesting. I like that idea of taking the algorithm to the data as much as possible, as opposed to trying to bring all the data over to the algorithm. I mean, why not? I guess it depends on the compute power that you have on board these different platforms. But when you say it like that, it makes perfect sense.
Yeah, it's exciting times right now. Those type of applications are really being focused on $1 million problems. I think, though, that the applicability of Earth observation data and what it's going to take to leverage it to solve some of our big global problems, it's really going to take us continuing to lower, create better accessibility so that we can solve for folks the $10,000 problems without, the amount of resources, because, it's pretty expensive still.
Absolutely. But I think in terms of access to data, one of the things that I thought about was, well, that's another way of condensing the data, right?
Absolutely.
And then that must make things cheaper and faster, and hopefully will mean that we'll get more penetration out into the market, because it'll be more accessible. So, like, from that side of things, it sounded really, really interesting.
Yeah, it absolutely is. It's exciting. My AI ML side of me says I still want some of the raw data coming down. So hopefully we don't just do that, because I think there's a lot of opportunities and that's been the whole excitement around machine learning, is to use data that was collected for different purposes and unlock hidden insights into it, and to ask it questions that we didn't collect it for to begin with. And that's exciting too. So I'm looking forward to the growth of the industry. I think having those algorithms on board, but also continuing to collect raw measurements as we discover more and more ways to use this data to answer more and more problems, because we shortly.
I completely agree. I've just got a couple more questions for you. I realize we're running short on time, but I hope you have time to answer these two questions. The first one is back to an idea we talked about earlier in the conversation, and that was data fusion. So primarily, when I think about Earth observation, when I think about remotely sensed data, I tend to think of one channel of data, one data stream. But I think that perhaps the opportunity might be in fusing data with lots of different kinds of streams. And we talked a little bit about that. Even if we stop collecting data now, could this actually be the real gold rush, with this fusing data instead of collecting more of it? Could this be the silver bullet, or the end game in terms of Earth observation?
It's interesting. I haven't thought about it in that terms before, as far as it being the end game. I definitely think there's a gold rush there. We're seeing some applications of that. And we at Astraea have done it where we've been fusing passive optical data streams. You can think uh, pictures with some of these active sensors, the synthetic aperture radar. That's been viable because synthetic aperture radar, while can be noisy, it has the ability to penetrate clouds. And traditionally in Earth observation, that's like clouds are the bane of existence of any remote scientist, you know.
Yeah.
And so being able to fuse those two data sources together creates, we've seen huge improvements in our modeling to be able to classify crops and other applications that we worked on. And so I think there is a lot of opportunity to fuse data that is, we're just now, I mean, it just now, literally in the last 6-9 months, really starting to see some compelling use cases. But you're right. More and more data streams, they do have a chance that as technologists that we can kind of get distracted by all the cool shiny objects coming as opposed to staying
Yeah.
with a focus and really finding that problem that technology answers.
Yeah, it's interesting. We keep coming back to like, yes, we've got all the stuff, we've got all these shiny objects, we could do this, this, and that, but it still really feels like we're both missing that use case. We've talked about a few different use cases, but you know what I mean? It feels like everyone's sort of fumbling in the dark, still trying to find a use case. They've got the shiny, they've got a tool, you know, where's the problem? I've got a hammer, where's the nail kind of thing. And I think that's really interesting. My final question for you is, so we often talk about being overwhelmed by these huge volumes of data, and for me, that often I always think of huge volumes of data. I think of Earth observation data, but as a geospatial professional, I work as a consultant in my day job. I don't often feel like I'm overwhelmed by my choice of building footprint data, for example,
Mm.
or the different road data sets I could use, and you know. Earth observation data is often the basis for a lot of this kind of stuff. You know, traditionally it would be digitized and then sort of make its way through the system down to people like me. When are people like me at the bottom of the data chain, if you will, going to see a sort of flood, a wave of data coming down towards us?
It's interesting. We're starting to see more. There's a lot more open projects, collaborations that I think will start to produce more and more data. I'm always encouraged by times where Microsoft just recently released their building footprints data set. There's plenty of data out there. To your point, the question is that a lot of the big use cases have been, I think, larger geographies, and I guess the question is, how do we enable folks that are focused on delivering localized solutions access more of the data, one, discover the data that is out there, and then know that they can incorporate into their analysis? Because I think there's actually more data out there than maybe perhaps you're aware of and have used in your traditional data. But in the fragmented marketplace we are in society, in this, it's almost like a death by 1,000 portals. It's really hard to find the data, the data that you can use, and in trying to fuse that together and have, that's one of our products at Astraea, our Earth on Demand, is focused on that data aggregation, data discoverability, and helping get to all these, pulling from all these different portals and put it into a place where you can discover it and then go get it from the different portals. And so I think there's actually probably a lot more data out there than typically is being used, but there's a cost that comes to that, right? Like you have a deadline, you have something to do, and data sources, and you trust those data sources. So how do we increase the visibility and data discoverability I think is a big challenge and opportunity.
Would you mind providing me with a link to that source that you mentioned? I think that'd be really interesting for our listeners to be able to follow up on that and come and check out that data discoverability tool that you've built.
Sure, yeah. You can go to earthondemand.astraea.earth, and it's a free tool that you can use. Doesn't require any big sophistication, no coding. It's simply interacting with the map, drawing your area of interest on the map and the time that you care about. And then you can start to see what, free imagery sources are available to you. And then you can look at those. We do the processing right there on the fly to let you see a natural color representation and then provide you capabilities to get to the underlying scientific data to incorporate.
That sounds really interesting. I will definitely include a link to that in the show notes. Daniel, this has been a fascinating conversation. I really appreciate your time. I really appreciate you coming along and telling the listeners a little bit about Earth observation. I think we've covered a lot of ground in this conversation, and I'm sure that the listeners have got some value out of it. So thank you so much for that. Where can we go to reach out to you if we have questions, or is there somewhere you'd like the listeners to follow if they would like to sort of follow along with your work and find out more about you?
Sure. You can check out our website, Astraea.earth. And then, of course, we're on Twitter and LinkedIn. Twitter, it's at Astraea, INC is our Twitter handle. So you can follow us there. And then we have, of course, a LinkedIn company page that we connect with as well.
And once again, I'll be sure to link those up in the show notes. Thank you so much for your time. I really appreciate it.
Thanks, Daniel.
So thanks again to our sponsor, OpenCageData. And I think that this really sums up OpenCageData. When you go to the website, under the frequently asked questions, there's two questions there that I think are really interesting. One is, do you make maps? And the answer is no. And the other question is, do you provide a routing service? And the answer is no. What they do, though, is provide an amazing geocoder, and they do it really well. So they're a company that's focused on geocoding, and they offer incredible service, and I can highly recommend these guys. If you have any geocoding needs, check out OpenCageData. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to say a big thanks for everyone who's tuned in again this week. It's much appreciated. If you could do me a huge favor, please share this podcast with a friend or someone you think might enjoy it. It helps the show grow. It helps us reach more people. It helps us spread the word about geospatial. I would really, really appreciate that. If you haven't subscribed, consider doing that. I've got a whole bunch more great guests lined up for you. And yeah, I look forward to bringing you more interesting stories from the geospatial world. As always, you are more than welcome to reach out to me on social media. You'll find me at Mapscaping on Twitter, Mapscaping on Facebook, and map_view on Instagram. I really look forward to hearing from you. Okay, that's it from me. We'll talk again next week. Bye.